Hey, what's up, Mal?
Hey, do you want to play some comp later?
Nah, we should probably work on the project, dude. Do you think you can come over anytime this week?
I don't think I can this week
Really? Why?
because my parents don't let me go out on weekdays.
Are you serious, Malcolm? I wouldn't have picked you if I knew this.
Dude, it's not my fault.
So what are we supposed to do the project on?
We can do it on Discord.
Really? Really, Discord. We're not doing it on
Yup.
Discord, Malcolm. Man, I swear, every time I work with you, dude, it's all. Alright, guys, so we actually did decide to do it on Discord, so let me just pull up Paint. Alright, now accuracy versus precision. Accuracy is how close you are to the actual value. So if I take this dart and throw it onto the dartboard, hit right in the bullseye, that would be an accurate measurement because it's right in the center where the bullseye is. Alright,
Hey, don't forget about precision.
Malcolm, be quiet. We're only doing this online because of you, okay? Now, precision is how close the measurements are to each other. So if I take the dart again and I throw it right here, that'd be precise measurement because the darts are close to each other.
Okay guys, I will be doing the making of a standard solution. Standard solution is one that has been made by dissolving an accurate mass of reactant into a known volume of water. This means that the concentration of the standard solution is accurate. So let's, for example, if we had 100 centimeters cubed of water in a beaker and then also 10 grams of the reactant, we added 10 grams of the reactant to the water, let it dissolve, stir it a couple times, then added it to a volumetric flask. If the meniscus of the solution doesn't line up with the line on the flask, just add some distilled water so that it does, and then from there put a stopper on the flask, turn it upside down a couple times to thoroughly mix the solution, and then you have your standard solution. And then from there, if you need to, you can work out the concentration of another solution that the standard solution reacts with.
Alright, so the next topic is going to be percent error. Percent error is a calculation to express accuracy of a measurement in a percentage. The formula is going to be the percentage of error is equal to the theoretical value, which is the value that you've calculated, or the given value of what you're supposed to get, minus experimental value, which is the value you actually got in your experiment, over theoretical value. You take the absolute value of that, and you multiply it times 100, and you have your percent error. Alright guys, let's say I'm going to make some cookies. You know, my famous cookies. The ones, they're the bomb, you know? Alright,
Okay.
excuse me. Anyways, guys, so let's say that the recipe calls and says it's going to make 20 cookies. I'd put that there for the theoretical value. But, you know, somehow I mess it up. I only make 15 cookies. So I would do 20 minus 15. You get 5 and put that over 20. And you would get 0.25. And you would multiply that number times 100. And you'd get your percent error to be 25%.
Okay guys, I will be doing nomenclature, which are a set of rules for naming compounds. So first is ionic compounds, which for metals in group 1, 2, and 13, you would need to add an IDE to the non-metal of the compound. So for example, calcium chloride. And then for metals in group 3 through 12, between the metal and the non-metal, you would need to add a Roman numeral for the charge of the metal. For example, lead 2 chloride. And then onto molecular compounds, you would need the prefixes. And so the first element in the compound does not get the prefix mono. And then the second element is available to all the prefixes, and you'd also need to add IDE. So for example, diphosphorus pentoxide. Then acids would be binary and oxy acids. So binary contains hydrogen and one other atom that isn't oxygen, and you need to add hydrogen in front of the second element and then add IC to the end. For example, hydrogen chloric acid. And then oxy acids contain hydrogen and a polyatomic ion that does have an oxygen, and so you don't have the hydrogen hydro in front. But if the polyatomic ends with 8, then you change that to IC. If it ends with ite, you change it to OUS. For example, HNO3 would be nitric acid, and HNO2 would be nitrous acid.
Last topic is colorimetry and the Beer-Lambert law. Colorimetry is used to determine the concentration of a colored solution based on how much visible light is absorbed. The color's intensity is proportional to the compound's concentration. So here you would have your colored solution, you'd put that into a cuvette, and then you'd put it into the colorimeter, and then it would basically shine a light through the colored solution and then see how much of it is absorbed. Now the Beer-Lambert law, which is equal to A equals ABC, where A equals absorbance, lowercase a equals the molar absorptivity, B equals the distance the light travels, which is usually the length of a cuvette, and then C is equal to concentration.